How to find and fix off-by-one errors in debugging. Imagine writing a loop that processes every item in a list, but somehow it skips the last one or tries to access an item that doesn't exist. That sneaky mistake is often caused by an off-by-one error. These errors happen when your code runs one step too many or too few, usually because of incorrect loop boundaries or array indexing. They are especially common in programming languages that start counting from zero, like C, Java, or Python. To spot these errors, start by carefully reviewing your loop conditions. Check if you are using less than signs versus less than or equal signs. For example, if your list has 5 items, the last valid index is 4. If your loop runs from 0 to 5 inclusive, it will try to access an index that doesn't exist, causing an error. Conversely, if your loop stops at 4, it might miss processing the last item. Next, verify your array or list accesses. Make sure your code doesn't try to access an index outside the valid range, which is from 0 to the length of the list -1. For example, if your list has 10 elements, the highest index is 9. If you accidentally use the length as an index, you'll get an out-of-bounds error. Using debugging tools can help catch these mistakes. Step through your code with a debugger and watch your loop counters and array indices in real time. If you see the index jump outside the valid range or skip over certain values, you've found your off-by-one problem. Adding assertions in your code can also help. For example, check that your index is always within the range before accessing the array. When fixing these errors, adjust your loop conditions. Change less than signs to less than or equal signs if needed, or vice versa. For example, if your loop currently runs while the index is less than or equal to the length -1, that is correct. But if it runs while less than the length, that is also correct. Just make sure the condition matches the number of items you want to process. Correct your array or string slicing boundaries to match zero-based indexing. For example, if you want to get a substring from position 0 to position 4, set the start index to 0 and the end index to 5, because the end index is exclusive. Use descriptive variable names like start index and end index exclusive to clarify your intentions. Document your assumptions about how your loops and indices work. This helps prevent future mistakes and makes your code easier to understand. Some programming languages have functions or constructs that handle ranges safely. For example, in Python, the range function can take start and stop parameters, and it automatically stops before the stop index. Always remember that in zero-based indexing, the last valid index is the length of the list -1. Off-by-one errors often happen when you treat the length as if it were a valid index. Testing your code with boundary values, such as empty lists, single-element lists, and the last element, can reveal these mistakes early. By reviewing your loop conditions, verifying your array accesses, and using debugging tools, you can catch and fix off-by-one errors efficiently. These small mistakes can cause big bugs, but with careful checking and testing, you can make your code more reliable and easier to maintain.